energy equations. These equations typically look like A equals B times C squared, right? Power for electricity is expressed in watts. The formula for power is P equals I squared R, or P equals R times I squared. But see, it's that same format. A equals B times C squared will give you a power. In electricity, if you have a measurement of the voltage and the current, P equals I squared, resistance. I'm forgetting my equations because I didn't write this down. So P equals I squared R is a energy equation for electricity, but it is an energy equation for many other measurement forms. It fits in those places. It's part of this inverse squared law that can be talked about for energy transmission. So, small nuance there, but it's knowing which factors to apply to make that equation work. I substituted the A for P. In my world, P equals power expressed in watts. In another world, P could equal ergs, which is a discrete unit of measurement typically used to describe molecular energy transfers. Those little cells in your body transferring energy from cell to cell to reproduce, to divide, to add, to subtract, to multiply, to bit shift left, whatever that magic is that goes on in there. That tiny little equation can be expressive of so many different pieces of energy conversations, I suppose. And there's no supernatural in it. You have to know what P is, what P I'm talking about. I'm talking about P as an energy factor for electricity, so that would be in watts in the room I'm speaking in. I would not have had to have clarified that conversation at all. I could have just walked in and begun at the door. P equals I squared R. R is determined by other equations, possibly, or a direct measurement, because we know how to do that as well. The other equations can be expressed as resistance or as impedance. Because in the room I'm in, the people know that as frequency in electrical current increases, there's a factor called impedance that looks like resistance to a measurement person not familiar with the rest of the rules. If he doesn't know of this impedance thing and it's on top of the R that might already exist, well, he might not have enough of the story to convince you about wave propagation through a medium. Maybe, if that means anything. But wave propagation through a medium isn't something that electrical engineers necessarily talk about. They talk about current flow and resistance and heat loss. They don't talk about ergs of energy transfers between a molecular structure. It's too tiny for their world. It's inconsequential in the measurements, kind of, unless you make it more complicated, which some people can. So there's power equations made extremely applied sciences.